Section 2.5 is absolute value equations and inequalities. We're going to evaluate and graph absolute value functions and look at solving absolute value equations and inequalities. Y'all have seen the absolute value equation somewhere in your past, haven't you? And you know that the absolute value equation will make a negative number positive and it leaves positive numbers alone. So sometimes we think of it as a distance formula. It's not really a distance formula. Sometimes we think of it or approach it as if it was talking about distances, because distances are always positive. If you're asked to solve an absolute value equation, you know that there's usually going to be two answers, one positive and one negative. For example, if I told you the absolute value of x is equal to 3, there's two answers, there are two values of x that would make this equation true, isn't there? X could be equal to negative 3 or x could be equal to 3. Because if x is equal to negative 3, that distance from 0 to negative 3 is 3. And if x is equal to 3, that distance from 0 to 3 is also 3. So whenever you have an absolute value equation, you want to set up two equations to solve. The first one, you take what's on the inside of the absolute value bars and you set it equal to the opposite of the right-hand side of the equation. And the second one, you take what's on the inside of the absolute value bars and you set it equal to the right-hand side of the equation. Now this is assuming that you've first isolated the absolute value bars. You've got to begin by getting the absolute value bars by themselves. You always want to isolate the absolute values. Can an absolute value be equal to a negative number? No. So if after you've isolated the absolute values you have an absolute value equals a negative, you would just stop and say no solution. Let's begin by analyzing the graph of y equals an absolute value function. If we were to just graph the line y equals negative 2x plus 4, that's what's on the inside of the absolute value bars. To get the graph of the absolute value function, I just take this red part of the line that's below the x-axis where y is negative and I just flip it up across the x-axis, and that's how I end up with this graph right here. I just take this bar and I flip it up and make it positive. So any part of the negative line will then be flipped up above the x-axis so that your y values are always positive because absolute values are always positive. That's how you analyze the graph of an absolute value function from the graph of the function without the absolute value. It just takes the negative part and flips it up. In example 1, we're asked to graph y equals f of x and y equals the absolute value of f of x and then discuss how the absolute value affects the graph of f. So in part A, we're going to graph f of x equals x minus 2 using blue, and then I'll come back and graph the absolute value in red. So if I'm going to graph this line, what's my y-intercept going to be? Negative 2, and what's my slope? Positive 1. So this is going to be a linear function with a slope of 1 that's increasing. When I graph the absolute value of this, the positive part's going to stay the same. This negative part then flips up above the x-axis and it looks like this. So in red, I've graphed the absolute value of x minus 2. In blue, I've graphed the function. In red, I've graphed the absolute value of the function. On part B, we have 1 minus 2x. What's the y-intercept of this line? 1. And what's the slope? So I'm going to fall 2, run 1 to get to another point, and then I just connect the dots using a straight line. So here's the graph of f of x. What's it going to look like when I graph the absolute value of f of x? Right here at this point, the graph is going to flip up all of a sudden, but this part stays the same. Like I said, when we're solving absolute value equations, your first step is to isolate the absolute values, keeping in mind that your absolute value cannot be equal to a negative number. Then you want to set up your two equations to solve. One of them, you take the inside equals the opposite, and the other one you just write it as is without the absolute value bars. Remember, when you're solving equations, you can always check your answer, and it's a good idea to do that just to make sure that what you've done is correct. Take your answer, plug it back into the original problem, and see if it gives you a true statement. So in example 2, we're asked to solve each of the following equations. Fortunately, in part A, the absolute value is already isolated, so I begin this process by setting up my two equations. My first equation is going to be 1/2 x plus 1 equals negative 5, and the second equation is going to be 1/2 x plus 1 equals positive 5. Now to solve this for x, what do I need to do next? subtract 1, and what you do to one side you have to do to the other. So that's going to give us 1/2 x equals -6. How do I get the x by itself now? You can multiply by 2 or divide by a half, however you want to do that. I'm going to put divide by a half, but that's the same thing as multiplying by 2, just simply because I can't get my pen. Wait, maybe if let me see if I can move that. It doesn't give me the horizontal bar to move. So I'm going to do this. And when I do that, I end up with x equals -12. Then we're going to solve the equation on the right. We'd still subtract 1 from both sides, and that gives us 1/2 x equals 4. To get the x by itself, I would multiply both sides by 2, and that gives us x is equal to 8. So my two answers here would be -12 and 8. And we can check our answer to see if they're right just by plugging in this value in place of x. Half of -12 is -6, and -6 plus 1 is -5, and the absolute value of -5 is 5. So that one checks out. Check the 8. Half of 8 is, and 4 plus 1 is, and the absolute value of 5 is 5. It checks out. It's a good idea or a good habit to get into to check your answers every time. On part B, our absolute value is already isolated, so I'm ready to separate this into two equations. What's the first equation going to be? Wait a minute. Are you sure about that? Can an absolute value be equal to a negative number? So immediately you stop and catch yourself and say that there is no solution. An absolute value cannot be equal to a negative number. So don't get in the habit of just breaking it, memorizing the process, break it into two problems and then set up and solve. Because you will get answers, but when you go to check them, you don't get the right answer. There's no solution anytime an absolute value is equal to a negative. On part C, we need to begin by isolating our absolute value. What do I need to do first? Add 3 to both sides. So you don't just look at this and say, oh, well, I've got an absolute value here and a negative here. There's no solution. You don't make that decision until you've isolated the absolute value. So this is going to give us the absolute value of 1 minus 2x is equal to 2. Now I'm ready to break this into two problems to solve. What's the first one going to be? And the other one? So what do I do first to solve this left-hand equation? Subtract 1 from both sides. Well, I'm going to go ahead and do that over here because I'm going to have to eventually anyway. Are y'all okay with that? I'll work them both simultaneously. That's going to give us -2x is equal to -3, and over here we get -2x is equal to 1. How do I get the x by itself now? Divide by what? -2. What you do to one side, you have to do to the other, and I'm going to go ahead and solve both of these simultaneously. So I end up with x equals 3/2 and x equals -1/2. So my solution set would be the numbers -1/2 and 3/2. There's two values of x that make this equation true. In example 3, we have an absolute value equal to an absolute value, but guess what? It's still an absolute value equation. I've got the absolute value isolated. I'm going to solve this by using the same process that I've already developed. I take what's on the inside of the absolute value bars and I set it equal to the opposite of the inside of these absolute value bars. And then I take what's on the inside and set that equal to the right hand side. Now I've got my two equations that I can solve because we have to take the opposite of the right hand side. So my first step here will be to distribute that negative, and that's going to give me 2x minus 5 equals -1 minus x. The goal is to get the x's by themselves on one side and the numbers on the other. So what do I want to do in order to achieve that? I'll add an x to both sides and add a 5. That'll put my x's on the left and my numbers on the right, and 5 minus 1 is 4. How do I get that x by itself now? What you do to one side, you've got to do to the other, so we end up over here with x equals 4/3. Over here, I want to get the x's on the left, so I'm going to subtract an x from both sides and then move the 5 over by adding 5 to both sides of the equation. And 2x minus x is x. The 5's are going to cancel out. 1 plus 5 is 6, so I end up with x equals 6 for my solution on this side. So my solution set contains the two numbers 4/3 and 6. And when you're typing your answers into my math lab, they're going to just ask you to type in your answers separated by a comma. Don't put these in parentheses. This is not an ordered pair. These are two different values of x that make the equation true. There's no parentheses here. It's just two answers for x. Next, we look at solving absolute value inequalities. Remember, the absolute value graph is this V-shaped graph. If we have a constant, an absolute value function is less than or equal to a constant, our solution is going to be everything below that constant value, and our answer is going to be on the x-axis. So the way that we would set up this inequality if we have a less than is we would take the absolute value equation less than k is equivalent to all of the x's in between these two solutions where S1 and S2 are solutions. So with the less than, you're going to set up a compound inequality. The compound inequality is going to look like this. We take the opposite is less than, the inside is less than the number that's on the right. That's how you set this up. This would be negative k is less than ax plus b is less than positive k. Whenever you have a less than, that's how you work the problem. If we have an absolute value function is greater than some number, that means it's a bigger than or it's above. Our solution is going to be out here to the left of this point of intersection and to the right of this point of intersection. So whenever you have a greater than, you set up two inequalities. The first one, we write the inside of the absolute value bars is less than the negative number. The second one, we just write it as is without the absolute value bars. And you'll see what I mean in a second when we look at these two example problems. So on example 4, we have an absolute value with a less than. I said whenever you have an absolute value inequality with a less than, you set up a compound inequality. So we're going to solve the inequality negative 2 is less than or equal to 4 minus x is less than or equal to 2. Whenever you have a less than, you set up a compound inequality. Your answer will be everything between the two numbers you end up with here when you solve this compound inequality. And I believe in 2.3 we looked at solving compound inequalities. The goal here is to get the x by itself in the middle. So what do I do first in order to get the x by itself in the middle? I want to subtract 4, but I do it to all three sections, left, middle, and right. What you do to one part, you have to do to the others. So that's going to give us negative 2 minus 4 is negative 6 is less than or equal to negative x is less than or equal to 2 minus 4 is negative 2. Is the x by itself in the middle? No, it's got that negative 1 on it. How do I get that negative 1 off? Divide by negative 1, but what do I have to remember to do when I divide an inequality by a negative? You've got to flip, so I'll divide all three parts by negative 1, but then I've got to remember to flip this inequality. So what I end up with is 6 is greater than or equal to x is greater than or equal to 2. Now, we don't want to leave it like this because with the compound inequalities, we want the smaller number on the left, the larger number on the right, and x in the middle with the less thans. So I can rewrite this as 2 is less than or equal to x is less than or equal to 6. And if I asked you to write this answer in interval notation, it would be the values that go from where to where, and do I use parentheses or brackets? Bracket 2, comma, 6, bracket, and that's my answer in interval notation. So when we have an absolute value inequality that involves a less than, we set up a compound inequality with the negative number on the left, positive number on the right, and whatever's inside the absolute value goes in the middle. Solve for x, write your answer in interval notation. Now when we have an absolute value inequality with a greater than, we end up with two inequalities that we solve. We're going to end up having two separate intervals for our solution. To set up the first one, I take what's inside the absolute value bars and I put this is less than negative 1. Use the opposite number, but if you multiply by a negative, you flip that inequality. And then for my second inequality, I have the inside of the absolute values. 3x plus 2 is greater than 1. I just write this one as is. But whenever I multiply by the negative to get the opposite, I've got to flip that sign. Now I solve each of these for x. How do I do that? What do I need to do first? Not add 2. Subtract 2. To move that 2 over, I've got to subtract 2 from both sides. I'm going to go ahead and work these simultaneously. So that's going to give us 3x is less than negative 3, and over here we get 3x is greater than negative 1. How do I get the x by itself? Divide both sides by 3. Do I have to flip the inequality now? No, because I'm dividing by a positive. If I were dividing by a negative, I'd have to flip the inequality. So x is by itself now, and I get x is less than negative 1, or x is greater than negative 1/3. If you were to graph this on a number line, which number would be to the left and which number would be to the right? If I have 0 here, negative 1 here, 1 here, I would have an open circle at negative 1 and shade to the left, and I would have an open circle at negative 1/3 and shade to the right. I've got two intervals for my solution set. So if I asked you to write your answer in interval notation, would I start with a parenthesis or a bracket? Parentheses, then what? Negative infinity, because remember we used the smallest value first. That goes off to negative infinity. So we have the interval that goes from negative infinity to negative 1, parenthesis or bracket. And then what do I do to connect these two sets? Union, and then parentheses, negative 1/3, comma, infinity, parentheses. And that would be your final answer. Any questions about solving the absolute value inequalities? The thing you've got to keep straight is what you do if you have either a less than or a greater than. What if I would have had a negative number over here? No solution. All right, one last example. We want to solve these using interval notation. How do I set this one up? Is it going to be one interval or two? That's a less than. So tell me how to set up my inequality that I'm going to solve, the compound inequality. Negative 5 is less than 3 minus 2x is less than 5. With the less than, you have a compound inequality with a negative number on the left, a positive number on the right. What do I do first to get the x by itself? Subtract 3, and what you do from one section, you've got to do to all three. And that's going to give us negative 8 is less than, the 3's are canceled out, negative 2x is less than 2. Now what? When I divide by negative 2, what do I have to remember to do? What are you worried about forgetting to do? Flip the signs. Don't forget to flip the signs if you multiplied by a negative. So, excuse me, what do I get now? Negative 8 divided by negative 2 is 4 is greater than, x is greater than negative 1. Do I want to leave that written like this? No. How do I want to rewrite this? Negative 1 is less than, x is less than 4. These are equivalent as long as you maintain that relationship between the variable and the numbers. Up above, when I looked at my inequality, the big end is towards the x, the little end towards the negative 1. When I rewrite it, the big end is still towards the x, and the little end of the inequality is towards the negative 1. You maintain that relationship. How would I write this answer using interval notation? Start with a parenthesis or a bracket? Perfect. You put parentheses on the numbers negative 1 and 4. Because this is a strict inequality, you only use brackets if you're equal to something, like in part B. In part B, we have an absolute value with a greater than. These are the ones that we have to break into two problems. The first inequality I get by taking what's inside the absolute value bars, and I set it greater than or equal to or less than or equal to. Less than or equal to negative 8. Remember, when you multiply by a negative, you flip the inequality. So to turn that 8 into a negative 8, I multiply by negative 1. I flip that inequality. The second inequality I just write as is without the absolute value bars. I have negative 3x plus 1 is greater than or equal to 8. And then I solve both of these inequalities individually. What's my first step going to be? Subtract 1, and what you do to one side, you've got to do to the other. I'll go ahead and solve these at the same time. And that gives us negative 3x is less than or equal to negative 9. And over here we get negative 3x is greater than or equal to 7. How do I get the x by itself now? Divide both sides by negative 3, but what else do I have to remember to do when I do that? Flip the inequality. So this gives us x is greater than or equal to 3, and x is less than or equal to negative 7/3. Before you write your answer using interval notation, it may be helpful to look at a graph of the solution set. I won't be asking you to do this in my math lab, but it is a helpful step, so you might want to try it. I've got two numbers here, and on the number line, the smaller numbers go to the left, and the larger numbers go to the right. Will I use an open circle or a closed circle when I graph my solution sets? Closed. So at negative 7/3, will I shade to the left or to the right? To the left. Remember, if you've got the x by itself on the left in the inequality points like an arrow in the direction that you shade. So my solution set's going to be this region over here. And then at 3 I put a closed circle and I shade to the left or to the right? To the right, because that's pointing to the right. Now can you write your answer in interval notation? Do I start with a parenthesis or a bracket? And then what? Negative infinity. Remember, you start with the leftmost value of that shaded region. That arrow's going off to negative infinity. Negative infinity is to the left of negative 7/3. And do I put a parenthesis or a bracket on negative 7/3? Bracket, union, bracket, 3, comma, infinity, parentheses, and we are done.